Okay, let's see. Show that at C, the pressure is 1 megapascals. Okay. Well, here's the thing that we know. We know the pressure and the volume at A, right? We know this pressure is 2.8 megapascals. And then we know that this volume is 1 times 10 to the minus 4th cubic meters, right? Okay. And we know that from A to C, we know that that is an adiabatic process, right? C to A is adiabatic. So what we can do is use P A VA to the 5/3 equals PC VC to the 5/3. And we know the volume at C. So we can, from this, we can figure out the pressure. We know all these things, right? So let's just plug it in here. Our pressure at A is 2.8 E6. That means 2.8 times 10 to the 6th, right? Volume at A is 1 E minus 4. And that's raised to the 5/3. Okay. And then that equals the pressure at C. And then the volume at C is 1.85 E minus 4. And we raise that to the 5/3. So to solve for this, we go this times this divided by this. Okay. So 2.8 times 1 raised to the 5 divided by 3 divided by 1.85. Notice I'm not typing in all this scientific notation because this one's going to cancel, and 5 divided by 3. Okay. And I get that the pressure at C is 1.004319 times 10 to the 6th pascals. I think I did it. Right? So now they say, what will show that the temperature is 254 kelvins, right? Well, 2 ways to do that to find the temperature. We know that this is 385 kelvins. Okay. And so this is, by the way, going to be cooler than that, right? Because this is an adiabatic compression that heated it up to 385, so therefore it started lower than that, right? I think the thing to do is to use the combined gas law, okay? So we're going to use PV over T is PV over T. And do the same thing. We'll go from A to C. Okay, so the pressure at A is 2.8 E6. Volume is 1 E minus 4. Temperature is 385. Is that kelvins? Yes. Okay, yeah, if it's Celsius, it's evil. You'll get the wrong answer. Okay, so this is at A, right? And then let's look at C. We know now that the pressure at C is... Now, here's the thing. You should use this. I'm going to use that. 0.04319. They're going to use 1 times 10 to the 6th, even though it's rounded. Okay, and then our volume is 1.85 E minus 4. And then there's the temperature at C, right? So now we can do math, right? I'm going to go that number that I've got there raised to the times 10 to the 6th times 1.85 times 10 to the minus 4th. Then I'm going to multiply by 385 and divide by 2.8 E6 and divide by 1 E minus 4. I'm just doing math here. Hopefully I'll end up with... And then indeed I get the TC is 255.47. Now, what if I just did it without that mantissa there? What would I get? Let's just try it. Let's get rid of that mantissa because they're going to round it. For sure, they're going to get rid of that. All right, let's just get rid of that. and then hit enter, and you get 254.375, right? So, so here's the deal. Even though that's the right answer, they're going to use this, and they're expecting you to use that when you do the subsequent calculations, even though it's wrong. That's wrong. That's not what you're supposed to do, right? So don't freak out if you don't round like I taught you to, and you end up with a slightly different number. It's gonna be okay. You're gonna be okay. This is what they wanted us to get. Okay. Anyway, don't freak out.